Hello and welcome to all students. Students, we are in the topic of chemical bonding, and in this or today's lecture, we are going to learn a formation of helium molecule on the basis of molecular orbital theory. In our last lecture, we have seen some introduction points about the molecular orbital theory, and in continuation with that introduction, how helium is going to be formed by the combination of atomic orbitals. The electronic configuration of helium atom is 1s2. Each helium atom contains 2 electrons. Therefore, in helium, that is He2 molecule, there would be 4 electrons. These electrons will be accommodated in sigma 1s and sigma star 1s molecular orbitals, leading to electronic configuration sigma 1s 2 and sigma star 1s 2. And the bond order of helium molecule is half of 2 electrons of first helium and 2 electrons of another helium. So bond order we are getting is 0. Helium molecule is therefore unstable and does not exist. Similarly, it can be shown that beryllium molecule has electronic configuration according to the molecular orbital theory is sigma 1s2, sigma star 1s2, sigma 2s2 and sigma star 2s2 also does not exist. And if we consider here lithium molecule, for lithium molecule the electronic configuration will be 1s2 2s1. Therefore, if we consider for bonding and anti-bonding molecular orbitals, the electronic configuration becomes sigma 1s2, sigma star 1s2, sigma 2s2, and the electronic configuration is also written as kk sigma 2s2. Why? Because this kk represents the closed K shell structure, that is sigma 1s2 and sigma star 1s2. So instead of writing this electronic configuration, we can write it as a ground state electronic configuration will be kk. From the electronic configuration of Li2 molecule, it is clear that there are 4 electrons present in bonding molecular orbitals and 2 electrons present in anti-bonding molecular orbitals. Its bond order therefore becomes half of 4 minus 2, that is 1. It means that Li2 molecule is stable, and since it has no unpaired electrons, it should be diamagnetic. Indeed, diamagnetic Li2 molecules are known to exist in the vapor phase. Now, if we came across some large molecules such as carbon molecule, that is, the electronic configuration of carbon is 1s2, 2s2, 2p2. There are 12 electrons in C2. For single carbon there are 6 electrons, and when 2 carbon atoms come close to form a molecular orbital of C2, so the total number of electrons now becomes are 12. And therefore, if we consider the electronic configuration of C2, it will become sigma 1s2 sigma star 1s2, that is ground state electronic configuration. Instead of, you can write it as a kk, and below of it we have written already sigma 2s2 sigma star 2s2 means electrons are present in bonding as well as anti-bonding molecular orbitals, and we are already familiar with it. Electrons which are present in 2s orbital are in number 2, and after that electrons are now going to enter in pi 2px2 and pi 2py2, that is both are present at the same energy level, so the equal to sign is we have taken. The bond order for C2 is half of 8 minus 4, means this number or this figure becomes equal to 2. 8 are the electrons which are present in anti-bonding molecular orbitals and bonding molecular orbitals respectively, should be diamagnetic. Diamagnetic C2 molecule have indeed been detected in vapor phase. It is important to note that double bond in C2 consists of both pi bonds, because the presence of 4 electrons in 2 pi molecular orbitals, in most of the other molecules a double bond is made up of sigma bond and a pi bond. For O2 molecule there is some change which you can notice here. The electronic configuration of O atom is, that is 1s2 2s2 2p4. Each oxygen atom has 8 electrons and hence O2 molecule there are 16 electrons. The electronic configuration of O2 molecule is therefore, we have going to look at its electronic configuration. Sigma 1s2 sigma star 1s2 sigma 2s2 sigma star 2s2 sigma 2px2. Look at this, the change which you have going to notice here. If we consider the electronic configuration of carbon, the energy level which is different from that of carbon here, pi 2px1 and pi 2py1 both are at same energy level, pi 2px1 and pi star 2px1 and pi star 2p1y. So this is the electronic configuration for O2 molecule. From the electronic configuration of O2 molecule, it is clear that 10 electrons are present in bonding molecular orbitals and 6 electrons are present in anti-bonding molecular orbitals. Its bond order now, therefore we can determine here, half of electrons present in bonding molecular orbitals and 6 electrons are present in anti-bonding molecular orbitals. So the summation of the equation becomes is equal to 2. Means if we consider the structure of O2 molecule, we will notice here in the oxygen molecule double bond formation is going to take place. This is because of that. So the oxygen molecule atoms are held by a double bond. Moreover, it may be noted that it contains 2 unpaired electrons in pi star 2py, pi star 2px and pi star 2py. Molecular orbitals, therefore O2 molecule should be paramagnetic, a prediction that corresponds to experimental observation. In this way, the theory successfully explains the paramagnetic nature of oxygen. And somehow, if we consider the hydrogen bonding in it, nitrogen, oxygen and fluorine are the highly electronegative elements. When they are attracted to a hydrogen atom to form covalent bond, the electrons of the covalent bond are shifted towards the more electronegative atom, and in the more electronegative atoms we have taken there some examples. You can notice the diagram which is shown in the present slide, how hydrogen bond is going to be formed in case of water molecule. Like that, the similar things can happen also in case of nitrogen and fluorine. This bond is this partially positive charged hydrogen atoms form a bond with the other more electronegative atom, that is, it may contains nitrogen, fluorine sometimes oxygen. This bond is known as hydrogen bond and it is weaker than that of the covalent bond. For example, the formation of HF. The hydrogen bond exists between hydrogen atom of one molecule and fluorine atom of another molecule as depicted below. This partial positive charge which is present on hydrogen and partial negative charge which is present on fluorine, which holds these two atoms by weak van der Waals force of attraction, and that bond we are calling it as a hydrogen bond, which is shown with dotted lines in between two molecules. Here the hydrogen bond acts as a bridge between atoms, which holds one atom by covalent bond and the other by hydrogen bond. Hydrogen bond is represented as by dotted lines, while a solid line represents the covalent bond. Thus the bond can be defined as the attractive force which binds hydrogen atom of one molecule with the electronegative atom of another molecule. Now why this hydrogen bond is going to be formed, that is cause of formation of hydrogen bond. When hydrogen is bonded to a strongly electronegative elements X, we have taken as example, the electron pair shared between the two atoms moves far away from hydrogen bond. As a result of the hydrogen atom becomes highly electropositive with respect to the other atom, since there is a displacement of electrons towards X. Because X we have taken in considered as a halogen, sometimes hydrogen acquires fractional positive charge, that is partial positive charge, while X, that is, attains partial negative charge, that is we have shown in the previous slide. As example, this results in the formation of polar molecule having electrostatic force of attraction, which can be represented as, that is, partial positive charge on hydrogen and partial negative charge on the halogen. Now there are different types of hydrogen bonds are present: intermolecular hydrogen bond and intramolecular hydrogen bond. Intermolecular hydrogen bond, now we are going to discuss here. It is formed between two different molecules of the same or different compounds. For if we consider, for example, the hydrogen bond in case of HF molecule, alcohol or water molecules, etc. Students should note that the difference between both of these two, that is, intermolecular means the bond which is formed between the hydrogen bond which is formed between the same or different compounds. Intramolecular hydrogen bond it is formed when the hydrogen atoms is in between the two highly electronegative atoms, that is, for example, we can take as a fluorine, oxygen, nitrogen within the same molecule. For example, O nitrophenol and the hydrogen, it is in between the two oxygen atoms, that is, in the above portion of this slide we have shown with an example. Such a type of bond we are calling it as a intramolecular hydrogen bond. So this is all about the today's lecture. Now students, along with this is the end of the chapter, and you can also revise from first video to the last video of this chapter, and this is very important chapter according to your basic concepts of chemistry, and many more examples and problems may be asked from this chapter for your NEET, CET and JEE examinations, and for theory exams also. This is one of the largest and important chapter and marks carrying chapter. So go into details about this chapter. Thank you very much.